Okay, we're going to do this example problem. This is use the following reaction. The reaction actually isn't written in your notes. By the way, guys, this is your notes packet. The example we left off on, it's page 4 in your notes packet, the very last slide. So that's your equation, the sodium hypocarbonate and then hydrochloric acid yields sodium chloride plus CO2 and H2O. And then it asks you to calculate the mass of sodium hydrogen carbonate necessary to produce 2.87 liters of carbon dioxide at 25 degrees Celsius and 2 atm. 25 degrees Celsius and 2 atm, this is not standard temperature and pressure. Therefore, we can't be using the 22.4 liters as a conversion. So we need to make sure that we're using the ideal gas law for this problem. So for the ideal gas law, remember the formula is PV equals nRT. And for this problem, 2 atm is our pressure. Our volume is 2.87 liters. N is what we're solving for. 0.0821 is our R value. And remember the R value has the 4 units, the ATM in liters and moles and kelvins. And then our temperature for this in kelvins is 298 kelvins. So when we multiply and divide to solve for N, we find out that N is equivalent to 0.234 moles of, remember this is CO2 that we just solved for. And now we take this and it wants us to calculate the mass of the sodium hydrogen carbonate. And they gave us all the information for the carbon dioxide. So what we solved for there was moles of carbon dioxide. Now that we have moles of carbon dioxide, we can use our balanced chemical equation that's up here to figure out how many grams of the sodium hydrogen carbonate is necessary to produce this quantity. So we do our standard 0.224 moles of CO2. At this point, we're in moles, so we can go directly into a mole to mole ratio. According to the balanced equation, for every 1 mole of sodium hydrogen carbonate, we have 1 mole of CO2. Last step, 1 mole of the sodium hydrogen carbonate has a mass of 84 grams. Okay, so moles cancel out and we'll be left with 20 grams of, and that is our answer. So to recap what we did here, we used the ideal gas law, plugged in all the information for CO2 that they gave us to find number of moles of CO2. Once we had our moles of CO2, we did a mole to mole conversion and then a mole to mass conversion to solve for the sodium hydrogen carbonate.